within the Erasmus IP seminar. Do you know what Erasmus is? Who was Erasmus? Do you know it? No. Do you know it?
That was a Greek philosopher, right? No?
Who was?
Some kind of philosopher or something. I know there's some universities named after him.
Yeah, you should know, because that is the umbrella under which we are here. Erasmus was a humanist born in Rotterdam. That's why we are coordinated now by the Dutch people. And he was born 1460, and he was studied in different countries of Europe, and afterwards he was teaching in different countries like France, Italy, Switzerland, Belgium, and he was of the idea that through knowledge the people can understand each other much better. That's why the European community decided to put in place such a program, which is called Erasmus program, and is working since 27 years. 25th was on 212. They celebrated 25th, and they spent billions of money for putting us together. Putting us together to create a real social network. That's a face-to-face network, because you see each other, you make real social networks with colleagues from the entire Europe. And that's why we came here. We brought here 15 students from Munich, and because Kasper made already some exercises with you, I would like that the German students stand up for 5 seconds so that everybody knows them. So we have 15 motivated students, very industrious, came here to get to know you and to get a lot of knowledges, of course. And so we came from Munich. Probably some of you know that Munich is in Germany, that is south of Germany, but probably you didn't visit it. So we have a short presentation of Munich, which was done during another type of Erasmus IP. And if you are so nice to start it. And I hope that all this equipment here is working properly.
One second for the authentication.
Okay, until he's done that. So my name is Alex Soceanu. I am with University of Applied Science in Munich, and it happened to be that we have the same Christian names. He's Alexandru Egner, and we are cooperating in doing quite a lot of teaching, research, and co-advisors of different activities on master, bachelor level on e-health, especially telehealth. And that's why we came here, among others, also to make some presentations on personal area networks, which are actually the medium where you are introducing or let's say ICT on the home place, as well as the entire connection with the rest of the healthcare institutions which take care of the people being home. And as we heard yesterday, before yesterday, the population is getting older, but even the younger population have to take care of their health. So if we take care of somebody at home, does not mean that it's only Oma or Opa. It's very well possible that one of us here may be operated by I don't know what kind of disease and has to stay at home and being taken care of. And this being taken care of became very expensive. And very expensive on both sides. On one side, that you have to travel a lot, and if you think at countries like Finland, like Norway, like Sweden, even in Italy, so the people have to travel a lot of distances to go to the hospital or to go to different healthcare institutions. That would be much better if they can be taking care of some of the parts home. That is one point. The other point is that the people who are taken care of, they are very expensive and they do not exist in the whole world as we would like to have them. Okay, if it works, start it. I hope.
This is Munich, a city with a special atmosphere, a city that is definitely worthwhile exploring. The former capital of the Kingdom of Bavaria lies in the south of Germany. It's located on the river Isar, with the Alps just around the corner. One can sense its variety from the many ways in which it is described. The northernmost city of Italy, the secret capital of Germany, Athens on the river Isar, the Million Village, a village of 1 million people, the cultural treasure chest of the south, the birthplace of the European Silicon Valley, the leading city in information technology, and the economic metropolis of Germany. No wonder that it is home to a large number of renowned universities and colleges. One of them is the Munich University of Applied Sciences. With its more than 14,000 students and 450 professors, it is the largest of its kind in Bavaria and one of the largest in Germany. It offers internationally recognized studies with bachelor's and master's degrees, quite a few of them with courses in English. Computer science is one of them. The Munich University of Applied Sciences has cooperation agreements with about 160 universities all over the world. The Department of Computer Science has always had European connections. Student exchange, for instance, with Great Britain, Sweden and Finland. Hello, my name is Klaus Köhler. I'm a professor of computer science specialized in IT security and programming languages. The demand for exchanges has increased since our students recognize the value of being able to work in an international setting. One of our fields of competencies is IT security. It is mandatory in our bachelor curriculum. Therefore, we are very grateful to the European Union for having accepted our proposal for an Erasmus intensive program on web application security.
I'm Alexandru, and I am specialized in computer network management. The latest development in web technology can only be properly used if the security of the access control to the networks and the security of the web applications are ensured. Our Erasmus intensive program on secure web applications, funded by the European Union, deals exactly with these topics.
I'm Johan Hertle. I'm specialized in entrepreneurship and data analysis, and I am the Dean of the Faculty of Computer Sciences and Mathematics. It is a great pleasure for us to coordinate and carry out this Erasmus intensive program together with such great university partners from Cyprus, Finland, Great Britain, Italy and Spain, and together with outstanding IT security experts from companies like McAfee, Siemens and Optimabit. What I find extremely valuable is the intercultural exchange of knowledge and the joint learning and teaching. For I am convinced the future success depends on the ability to collaborate in an intercultural and international environment.
I'm sure that at the end of that Erasmus IP, we will have all of us the same possibility to look back to a film like that, with more contribution of all the other students. Okay, so where am I? Yeah. So we would like to talk very shortly about the personal area networks, which are part of the e-health connection. And of course, we will have shortly a demo based on a biometric security protection in supposing or for the new standards which are introduced for personal area networks. So I would like to talk about a little bit about the problem which we encountered, state of the art for interfacing personal area networks, standard architecture and interfaces which are already announced and used in some of the parts. Then about the protocol family which is known under the name X73, about the other protocol extension of Bluetooth part, which is very much used especially for this kind of application on patient area at home. So Bluetooth Health Data Profile is that called. And we would like to speak a little bit about the IEEE standard, which is introduced 3-4 years ago, and because it does not contain sufficient security, we did some efforts to extend the authentication, and Alex will demonstrate here a system, of course, simulated on the computer, how it works. So, of course, like we have listened very often in the last 2 days, the purpose of medicine is to prevent significant disease, to decrease pain and postpone death. And that was the reason why we need technology and why we are here to learn how to use technology for that purposes. Which are the benefits of the people who are using them? Home telehealth is an appropriate and cost-effective, like I said before, and proactive integrating care reduces critical care and improves very much quality of life. Telemonitoring, e-health management improves quality of life and healthcare expenditure cost. Of course, if we look now to the very famous grandma who is at home and needs measurement of the vital signs, so there are a set of devices which are used for having the pulse oximetry, for having the spirometry, for having many other, the temperature and so on, as well as how she is sleeping, how she is walking, and so on. And all this information is supposed to be sent to the primary care, to eventually ambulatory if the situation is very serious, or to pharmacy to give them medical. And all this information should be sent to healthcare institution where they have some specialists, test results, and bring back or correct the diagnosis. Of course, if you look at this diagram, so you may ask, okay, why do I get such a system? Of course, if you try to go on the market to see where can I buy something, so you end up, for instance, I give here some examples, so you end up to Philips. They will offer you a set of devices, all from them, and all these devices can be used in connection with a telestation. The telestation is transmitting the data to a care manager. The care manager eventually take into consideration also a help of a physician, and that physician at the end, after the analysis, will come back to the patient saying that has to increase the number of pills they take, or reduce or come for an additional checks. Okay, then if you don't like to buy anything from Philips, you go to somebody else, and you go to Bosh. Bosh has their own set of devices. They measure all the corresponding vital signs. They have their own base stations. They have their own telehealth platforms. They have their own system appreciating or evaluating all this data. And at the end, per telephone or any other type of connection, they address a patient. Yeah, if you don't want to buy from them anything, then you go to Graz, to Fachhochschule Johanneum, which we have heard last time. Okay, they succeeded to put together some of these devices, and if they continue working, they probably put it on the market, and you will have here devices like this, put it in a nice suitcase, and then you can use some of what they consider, or they put it together to work together. So now try to think that you buy some of the devices, one from Philips, one from Bosch, one from Graz. Do you believe that they will work together? Do you believe that in the future we do not have to think of wishing to implement or looking into the standards to be able to create these innovative ideas, put on standards? And most of you are somehow connected to your university where you got some information about networking. And if we try to look at the architecture which is presented, or let's say an architecture which is recommended by one of the very strongest association called Continuum Health Alliance, they are having such an architecture saying that if you are at home at a so-called personal area network and have a set of devices like we have seen in the last days, like for instance thermometer, EKG, pulse, blood, weight scale, and so on and so forth, then would be very important to be able, all these devices which may be manufactured by different type of companies, to be able to connect them to a local hosting device, which may be a smartphone, a PC, or a station, an oriented station, and from here on, this data which are connected to the corresponding patient should be transmitted to a telehealth service center, and from here to a central center where this is analyzed and especially afterwards connected back to the patient. Now if you look to that very simple architecture and project it on architecture which today is recommended for including at the country base, And some of the countries started already to introduce this kind of architecture. Then we speak about electronic health record. And it's very possible, and it is expected that in the next years, most of the European countries will have at the country level an electronic medical record, which will record all the health information about all the patients of a nation. And this is connected to different type of so-called stakeholders who are participating to our e-health care. And it starts here at that level. That means it starts here at home, where you get vital signs measured by different type of devices. They will be transmitted using a standard protocol, and this information will be included into the electronic medical record. And from here, all the other stakeholders are able to read that information and supply different type of care. So what do we have here? In case of hospital labs, we have, and here there are other standards, and Alex will speak about this standard on next week on Monday, I guess, about the very famous HL7. Probably some of you heard about it, some not, but now you hear about it. Health Level 7. Health Level 7 is a set of protocols, conventions, quite large and demanding for all the companies who are writing this kind of software, and probably you will come to the point to work on that. And then they transmit the information, use HL7. Then radiology is transmitting information, probably you heard about it, DICOM-Edge. In Germany, most of the hospitals are using this kind of protocols, including the information on a local base, not at the country base. Then you have hospital pharmacies, external laboratories, community pharmacies. Of course, the assurance company who are paying for all these kind of treatments, they have to get the information about the treatment recommendation cost in order to be able to pay. And of course you have quite a lot of software which is dealing with admission, transfer, discharge, and all the connections are based on HL7. So that is a chart which in some of the countries, and I can tell you, for instance, Turkey has at the moment 60 million people registered with such a system. I cannot tell you if all the connections are there, but they will continue to have that. Germany is a little bit behind of some others because we have, I will say in German, Bedenkenträger. That means we think 10 times of all the security problems which can appear, and we do not continue working introducing these kind of systems, but we will come up. The Americans are very, very advanced into that. They introduce already 3 stages of introducing electronic medical records, electronic health records. At the moment, at the physicians' studios or the physician place, and with quite a lot of functionality, and slowly they move into the central situation. Okay, that is the picture which you will see in the next time, and also in the publications which are dealing with e-health and e-health systems interoperability. If we do not take care of interoperability, we are not able in the future to have any e-health system. And I remember the time when we were working with different type of computer networks and computer. Each Siemens has their own system, their own terminals. IBM, they had their own terminals. Then it was a time when the PCs could not connect to each other and have the possibility to work different programs from one to another, independent who manufactures one or another device. We will come up to that at the same time. Okay, let's look at the personal network, which are the domains where we apply it, not necessarily only for OMA and OPA. So we discuss about disease management, of course, for the ones who are at home and need care. We speak about health and fitness, and most of you are doing that. And most of you would like to know how your body is reacting to different type of activities you are doing and adjust it according to the measurements which you have. And of course we speak about independent living, aging independently, which we have seen before, that some of the associations are taking care that the people are able to live in their home without being, without going to different hospitals and so on. Okay, so the interfaces, what do they support? We have seen several, especially yesterday by colleagues from Graz. So we see that we are able to support on all these systems Bluetooth, USB, Wi-Fi, etc. And of course we have to speak about the way how the data are exchanged. We have to do this connection according very efficient and secure, and targets personal health in home and mobile environments. These are the reason why we have this kind of interfaces. But let's have a look how the standards look like and what do they expect from us to implement. By the way, meanwhile, we still have libraries with a lot of software which is already certified by Continua. That means if we would like to enter into that area, would be very good to see what the people already offered to us, like Gaspar told us that we have Linux. Please look at this. Many thousands of hours were worked to put that on place. And this is a way how the point we should start. Okay, so we speak about two parts of that concept. We speak about an agent and we speak about a manager, not server, but manager. The agent represents a device that collects personal health data. These are the devices which are EKG, thermometer, scale, and so on. Those devices are the agents collecting data and transmitting them. And a manager represents a device that collects personal health data from the agent, and not very in a very structural way. And that is what the standard is telling us, or the way how the standard is recommending and implemented this kind of structure. So we architect. So we have, like, you know, if you call back your memories on computer networks, we spoke about 7 layers protocol stack. We have here only 3. We have a physical layer, which is a data link and physical layer. Data link and physical layer is supporting Bluetooth, HTTP profile, USB, Wi-Fi, infrared data, and so on. That is on the level, and we have seen yesterday that some of these are already in place. You don't have to do anything. The physical layer is there. Then you have a transport and communication layer with 3 models. One of the model is communication model, the other one is service model, and domain information model. We will talk shortly about it, and on top of it, you have the application layer. That means that is the corresponding agent. The agent, that means a device which is measuring the corresponding vital signs, like thermometer, blood pressure, weight scale, and so on. That the architecture of the protocol, and it has to be fast, of course, and doesn't have to use too much resources from the agent, because the agent is a very small device with not that much energy, and that's why it's good to have this kind of application. Okay, so what do we have? We have the data link, I said Bluetooth, mainly Bluetooth HTTP, and we have to add on top of it that Bluetooth got recently a new profile. Bluetooth has quite a lot of profiles for telephone, for fax, for printing, but one of it is health data profile, which have been introduced specially to support this kind of application. Then we have the communication model, manages the connection between the agent and manager, and domain information model. That means the data which are taken by the agent from the body is put in a special structure, and you can use this structure, not invent it once again, but use it. Kaspar talked about router or router. What did you find out?
It's router.
A router, okay. He didn't say that the router has a management information base, quite a lot of information which is structured, and everybody knows how it's structured. All what you have to do is to query this information which is on the router, and you have a picture of what happened with the data which transferred the router, which the data was stopped by the router, and so on. So that's why I speak about domain information model, and this kind of protocol is precising where the data are, how do you get the data, and when do you get the data, and you can set it up. And you will see that Alex will make a demonstration showing you how that it works. Then you have a service model, defines interaction, of course, with a lot of commands which you need. And all of this information which is contained into the agent and the manager is written in an ISN1, abstract syntax notation. One is very simple, it's even easier than Python to understand, and that's why everybody who does this kind of applications is very fast able to read how the structure looks like. And this is included into a special nomenclature. Alex, you have to pay attention of my time. Tell me when the time is finished. So, at the moment, that standard is already announced as a final standard for a set of agents like pulse oximeter, like heart rate monitor, blood pressure thermometer. There are around 12 to 14 agents which are already announced as a final definition, a final standard. Let's have a look. What happened in the last time, and we did this kind of experiments, and you will see there. What we have what they call it an HTTP source. That means this is on the agent side, and we have an HTTP sink. And we have here the host, that means is the agent, which has a corresponding protocol with the three layers on it, and you can connect it via Bluetooth, as you see here. On top of it is HTTP, a layer. Bluetooth has a lot of layers. I don't want to enter into that details, but all these electrotechnic specialists from Graz, they might understand it, and all the others. And if you have the connection here, on the other side, you have on the agent, on the manager, which can be a smartphone, or can be a PC, or oriented Linux platform, no problem. So you can put it here and do the transmission. And of course you have the possibility to do it even compactor. So we were very surprised 2 years ago to find out that next door to FTech Metropolia, okay, let's say to Metropolia in Leppävaara. Next to it, there is a company very, very advanced, and it's called Blue Giga. This Blue Giga company has the idea to put this new protocol on top of a Bluetooth chip, and it cost 50 cents. And we got it for free just to do some tests. And we did the test, and it works. And that means you have a Bluetooth chip which contains the whole protocol, inclusive application, and he will demonstrate you that you even can set it up for thermometer, Bluetooth measure, and so on. About 10 or 12 types of agent is possible to be selected. And on the other side, we have a manager, and there is a library of software for that protocol, which is written for a smartphone, but we adapted to be able to work on the corresponding PC on under Windows. Linux, excuse me. Okay, under Linux. And we have among us here one of the students who will present today in the afternoon a presentation. I don't know if you will tell us something about MDR, but Sebastian was able to do a plug-in for Wireshark to be able to understand that protocol. So we are in that phase in which I consider that is fantastic, that the students will work on that which already existed and put a step or put a layer on top of it. Okay, so it's not that complicated to think of how it works, and because we are able to do these kind of measurements. So you see that first of all, in a service model, we have a set of messages like request, like response, like terminates, like response for the terminates, and we have a set of commands. Of course, we have a command for get information, set information. We have reports, that means the whole data which were already measured, they are transferred, and a set of action. And we have in the communication model 4 phases. We have a phase which is associated. That means you associate agent and the monitor by using the protocol, which is already standardized. Then you have configure. You can configure your agent to work like you would like to have the data immediately every half an hour and so on, and you have to indicate also some IDs for it, and then the connection is in operating form. That means you transfer the data from the vital signs into the other side and you disassociate. So we have a lot of protocols which are able to see on the wire by using the corresponding Wireshark for associated message, for confirmed messages, and for unconfirmed messages. And just to give you an idea, probably you have seen very often this kind of diagrams in which you have, for instance, the manager. The manager knows the agent configuration. So the manager is saying, please give me the data, and put here a set of parameters. So the agent is saying, I would like to connect with you, and the manager is responding saying, okay, I accept you because I know you. I know you because the agent indicated the IDs. So it's very well possible that the manager does not know the agent. And if in that case, if I would like to make the association, the manager would say, okay, I'm sorry, I don't know you, you should identify yourself. And here is the protocol flow in case you are already associated, you send the data are confirmed. No, excuse me. So the data configuration ID, okay, the agent sends the configuration ID and the manager is confirming that accept all configuration and so on. Then transmits the data. Then transmission of the health measure data of status, all the data are confirmed, and in that case we are sure that the data came to that station, to the manager, in the same form as they were transmitted. Then it's very well possible that you have many data to transmit, so many messages to transmit one after the others within a time which you set it up, and you have many data, and you confirm all the data at once. And the problem is, it looks nice. When they standardized that protocol, they thought that one patient is at home and the information is taken from that patient into the manager. And because of that, they didn't introduce any security and privacy into that protocol. And we tried to improve it, to enhance it. And of course, privacy and security of data is of very much importance today, and you cannot, all the applications which I have seen, and if you think of an application which can be taken by a company to be continued, you have to think of at least to have some ideas, propose some ideas how do you deal with privacy and security. And this is very important to know that the specification even wrote that. They said, we do not take care of safety, security, health, environment protection. The implementers of the standards are responsible for it. It's just for you an idea of doing some other projects. If you continue thinking of this type of area to go into as engineers or software developers, you should think of and do some improvements. Alex, that's it. It follows. Okay, so all what we have done, we've done an authentication for manager, a patient authentication. We don't have time to show you everything, but he will show you a demo.
Okay, thanks. Hi again. I would like to begin with a short recap and an overview of the presentation. Sorry, in the microphone. Yeah. Okay, until I finish with the setup, I would like to make a short recap on what we've done and what we've presented, and how this links to the other parts that everyone presents here and the things that you students are doing, so each project individually. So let me start with the beginning. You build e-health applications, okay? So we've seen yesterday you built some monitoring system. Am I right? Students from Austria, you build a setup where you have some sensors for measuring all the information. You get those information and then you do something with them. You just build a setup, okay? This is the first step. You, on the other hand, Gaspar, you told us how to interface with an embedded system based on Linux, and how to use routers or other boards for acquiring information and interfacing, managing the sensors, and so on. So this would be the first step, how to get to the data. The second step is how to use this sort of data. So you need transmission, you need some sort of communication. So this is why the presentation was intended to offer you an overview of communication standards, architectures based on e-health systems, and a bit of a short demo on one of these standards. I would like to emphasize one important thing here. This is related to security. Whatever applications you are building for e-health domain, you should consider the security aspect. So the privacy of the data and the security of the data is one really important aspect of developing these sort of applications. This is because you don't want people to know which time grandma goes to knitting class or to bungee jumping, so you should keep that private. Okay, so I would like to show you a short demo. Of course, the setup is under Linux. So what we've built, we took one of these protocols that Professor Soceanu already mentioned. By design, the protocol had no reference to security. The security was set to be taken care of by developers. So this is exactly what we've done. We've managed to build an authentication system based on biometrics. It's not a traditional biometric authentication that you can think of. So I will take just 1 minute to tell you about this authentication system, and then I will show you the demo. So normally what happens is when you use fingerprint readers such as this one, normally what you do is place your fingerprint there. There is a database, let's say FBI tries to identify you. There is a huge database of fingerprints, and whenever they take your fingerprint, they match it with one of the fingerprints in the database. If the fingerprints match in 80 or 90%, there is a 90% matching score, then you consider that the fingerprint belongs to the same person. It's never 100%. It's never 100% because the biometrics change throughout time. Even though I place my finger here on the same fingerprint device now, and I press it again within 2 seconds, the fingerprint looks a bit different. So it's never 100% exactly the same. What we try to do is to replace the traditional authentication system based on matching with an authentication system based on biometric keys. So what you do is take all the relevant part from the biometric data and convert it into a cryptographic key, which you can use in any security. So this is, for instance, how my fingerprint looks like. We extract some features. So these are the sort of points that give the uniqueness of the template. I then generate a key. Okay, and this is sort of a key. So this is just a demo of how a biometric key looks like, judging from this biometric template. And Sebastian, as I understand, will show you more on this Wireshark plugin. For now, I will only show you the fact that during communication you can you can acquire data. You can see the data that's coming from one place to another, and this is a really important reason why you need authentication. So I will start the Wireshark. This is the button. Sorry, the wrong button. This is the one. Okay, and I will start the connection between a manager and the agent. And then associate. And if I
Can
go
you
back
not
to
make
the
it larger?
Wireshark,
Alex,
yeah,
can you not make it larger?
I'm not sure if I can.
Okay.
Sorry. Okay, so this is the sort of messages that I can see going throughout the network, and this is why you need this sort of encryption or authentication systems, because data is sent in clear text. You don't want that. You don't want to know when grandma is going to bungee jump or Martha. And as this is a short example of, let me choose this one in association with response with the acceptance and increased. Okay. So this is an example of how the protocol is interpreted. You don't have to know every of these extra values, but you can see here that you can dissect the whole message and see what sort of fields and what sort of values those fields have. So this is an example of the biometric key intercepted from the communication channel. In this case, we let the biometric key be sent directly on the network, so you can see it that it can be intercepted. So, to wrap it up, because I don't have any more time, you need to consider security. So, security is one of the major aspects why e-health systems are not adopted, for instance, in Germany or in Holland as well, as far as I know. At the national level, the biggest problem right now is how to ensure privacy and security of the data. You have communication protocols, such as this one, that are very nice and very powerful. You can send a lot of information from one place to another. The problem is that you don't have security in order to mask the information that is sent. And this was a short demo about